Hello everyone and welcome back to Gyan Mastermind, an exclusive learning platform for electronics and communication engineers for GATE and ESE preparation. Before we start the session, note down the following guidelines. First guideline, use an earphone or headphone for better experience. Second guideline, take notes for better focus and understanding of concepts. Third guideline, do watch till the end of this video for immersive learning of the concepts. The last guideline, leave your questions or comments down below and I will do my best to answer them. Today, we will see a quick introduction to communication system. Coming to the outcome of today's session, we will be seeing what is a communication system and the elements and also layers of a communication system, and Shannon's contribution to communication system, and also practical realities in a communication system. We will be seeing the components present in the transmitter as well as in the receiver, and also impairments of a communication channel. What is communication? The term communication means transmission of information from one point to another. The term tele in the word telecommunication means far. However, modern applications of communication system includes Bluetooth and Wi-Fi, etc. Hence, the word telecommunication might be inappropriate to use. Instead, we use communication itself. The list of applications involving the use of communication is almost endless. Few of applications includes telephones, radios, televisions, internet, and also transmission of information between ships, aircraft, rockets, satellites, as well as weather forecaster. Coming to the elements of a communication system. The first is information source, then comes network and control layers, then transmitter, and then channel, and then receiver, again network and control layers, then information sink. As of now, just ignore the network and control layer. I will explain them soon later. First is the information source. The information may be voice, music, pictures, videos, or any data files. Second is transmitter. The role of the transmitter is to process the information such that the processed information is suitable for transmitting over a channel. For example, in FM transmission, music signal is frequency modulated for radio transmission. Third component represents the channel or transmission medium. The transmission medium may be a cable, an optical fiber, or free space. Fourth represents the receiver. See, the role of a receiver is typically greater than the inverse of transmitter. You can see the receiver is simply the inverse of transmitter, but in practice it is not so, because the channel over which the information is transmitted may have some impairments which would have degraded the actual information. For example, receiver have to compensate for distortions in the channel and also perform other functions such as the synchronization of the receiver to the transmitter. The final component is the destination or information sink. Coming to the network and control layer. They play an important role when there are n number of transmitters and receivers, because they permit the multiplicity of terminals to reliably and efficiently share the same physical medium. Layers of communication system. Here is the 7-layer model illustrated by the Open Systems Interconnect, simply OSI, for computer communications. Each layer represents a protocol. Consider this as the sender and this as the receiver. The message from the sender is transmitted over a physical medium to the receiver. In practical, sending message travels down the stack of these layers across physical medium and goes up the stack on receiver side. Only physical layer communicates directly with physical layer at receiver side. Other layers can only communicate virtually. This layered model is best suited for digital information. As of our study, we will consider only physical layer of communication system. Shannon's contribution to communication system. Shannon is known as the father of information theory. He laid the theoretical foundations of digital communications. Before he published his papers, it was believed that increasing the rate of information transmission over a channel would increase the probability of error. He was the one who proved that this was not true unless the transmission rate exceeds the channel capacity. And also, sampling theory, Boolean algebra were some of his significant contribution to the digital circuits. Practical realities in communication system. Most modern communications are digital. We should be aware of analog techniques because of 3 reasons. First one, in order to understand the digital systems, we must have knowledge of analog techniques. Second, analog had issues. Only to counterpart, many digital communication techniques have been evolved. And third one, many of the distortions observed in the digital transmission are of analog in nature. Components of a transmitter. The 4 major components are protocol stack, modulator, up conversion stage, and RF stage. Protocol stack. In applications like point-to-point radio systems or broadcast radio system, this component is not of use because there is no need of destination address information. In case of sharing the radio channels, we need multiplexing of multiple signals, which requires this component to transmit reliable information to the intended destinations. Modulator. We use a carrier signal to carry the actual information to be transmitted. So, it should be modulated in a manner such that the actual information recovered at the receiving end. Up conversion stage. It does the same job of a modulator. Modulated signal is converted to the final radio frequency. But nowadays, modulator is replaced with the direct to RF. It means that the information or message signal is modulated at radio frequencies. Coming to RF stage. The signal is amplified to an appropriate power level and then emitted via antenna. The modulated signal converted to electromagnetic wave, and the power output is directly proportional to the desired transmission range. And the type of antenna is dependent upon the frequency of operation and applications. The type of antenna may be pip antenna, parabolic antenna or horn antenna or dipole or patch antennas. The modulation technique is very important because the modulator chosen must be easy to implement, performance as well as the capability to combat channel impairments. Impairments of a communication channel. The impairments or propagation loss, frequency selectivity, time varying, non-linear, shared usage and noise. Coming to propagation loss, a loss of signal strength naturally occurs with increasing distance. Frequency selectivity. The channels operate over a medium and that medium performs well only over a relatively small range of frequencies. Time varying. Some channels are time varying, that is, their characteristics vary with time. For example, in mobile radio channels, shadowing and fading occurs due to time varying characteristics of the channel. Non-linear. Ideally, the channel must be linear in order to minimize the distortion of the transmitted signal, but not possible as we are forced to use amplifiers which produces non-linearity. Example, satellite channel. Shared usage. To make efficient use of channels, they are often multiplexed. Multiplexing leads to interference between users if perfect isolation is not provided. Noise. Our motto is to achieve a communication system with maximum transmission distance with minimum transmitted power, which leads to unavoidable presence of noise. So, we have to choose a suitable modulation strategy to combat these 6 impairments. Components of a receiver. Most of the components of receiver are the inverse functions of the transmitter. RF stage. The antenna collects RF signal in the desired frequency band. The collected RF signal contains both wanted and unwanted information source. Therefore, a low noise amplifier is used to boost the signal power so that noise can be minimized. Down conversion. Either the RF signal is translated to a frequency where the message signal can be easily demodulated or translated directly to baseband, which is direct down conversion. Demodulation. This is the stage where transmitted message signal is recovered. It consists of a sequence of linear filters. Synchronization. There is need of synchronization because time and frequency clocks used at transmitter and receiver differ. Example, we use phase lock loop to achieve synchronization. Channel compensation. We use some advanced techniques like equalization and forward error correction for noisy channels. Protocol stack. As already described, it determines the detected message was intended for it or not. Overall, the design of receiver is more complicated than that of transmitter because at receiver it has more unknowns to deal with and the signal strength is much weaker. So, we have to choose correctly the modulation as well as the corresponding demodulator. Hence, in this session, we learned about basics of communication systems, elements and layers of communication systems, and Shannon's contribution, as well as practical realities in communication system. And also, we have detailedly saw components of transmitter and receiver, as well as the impairments caused during the transmission through the channel. So, I hope to see you in the next session soon. Alright, that's all for the session. So, I hope to see you in the next session soon. Thank you all for watching. To stay up to date with the latest videos, make sure to subscribe to the channel by clicking the red button below this video and hit the bell icon. Thank you.